All right, for the side-side angle problems, we did these with a couple of constructions. And there's basically two groups when you have the three numbers. I could group this as 3, 7, and 60. Problem number 2 would be in the other group. If you see if you can figure out why, again, each group based on what we talked about from 2 days ago. Number 3 would be in the right group. Number 4 would be in the left group. And number 5 would be in the group on the right. So think about for a moment before I continue. Why is problem number 1 and 4 paired together, and why are the other 3 problems paired together? So these are all side-side angle problems, and the reason why the problem on 2 on the left pair together is because you basically have the short side followed by the longer side followed by the angle. And for the second group, it's the longer side followed by the shorter side followed by the angle. So when I wrote these out a couple days ago, I made sure that I made the distinction between the size of the letter S. So the first one is short side, long side angle, and the second one's long side, short side angle. Now, of the two groups, one of them always produced one triangle, and that would be the group here on the right. So sometimes we have numbers, we can actually look at the side-side angle cases and identify which ones will work. If they have just tick marks, generally the answer is always no. There is one exception though, and that's when we have a 90-degree angle. And this goes along with problem number 6. With these two problems here, what's the special name for those? So if I would draw both of them out, they have a right angle, you have 10 and 7, and the second one has also a right angle, and the two sides are 13 and 5. And so the 10 and 13 are both the hypotenuse of the respective triangles, and the 7 and the 5 are called the legs. And the other two unmarked sides are also called legs. So for a right triangle, if we're not talking about trig, the lengths are labeled hypotenuse or leg. So the special case for side-side angle that your textbook does use is hypotenuse leg congruency. We talk about the fact that if I have two triangles that have the lengths of 13 and 5 as the hypotenuse and leg, that if I use the Pythagorean theorem, I can find the third side for each of these, and the third side would be the same number. I could also use trig to find the angle in the bottom left corner, and using cosine, I could prove that those two angles are also the same. So the one thing about side-side angle is because of the Pythagorean theorem and our right triangle trig rules, we can actually prove that the two triangles would actually have all the same numbers. Hopefully that helps with this activity, and hopefully you did well in determining which ones worked and which ones didn't.